Borrowing and shared reference. Borrowing is how you give a function access to data without giving away ownership. Think of it like lending a book. They can read it, but they don't own it, and they have to give it back. We use shared references, which is a read-only access. You can have as many shared references as you want simultaneously. Many readers, no writers. While if you're borrowing T, for example, while it's active, the data is guaranteed to be immutable. The compiler enforces it. Zero code subtraction. A borrower is just passing a pointer. Fast, no allocation. So always prefer borrowing over cloning when you only need read access. Let's see borrowing in action. So we're going to create a function. Fn length s. This is going to be a string, but we're going to be borrowing it. And we return a usize. s.len. Now in the main class, let's let s equal string from hello. Let n equal length, then we're going to put s in the parameter, but we're going to borrow it because we're reading it. This will lend s to length, and since we've lended, it means that we still have access to this. We haven't changed ownership, so we can print both. We can print both n, s, both s and n. So s is of n characters. So both of these values are valid. So hello is 5 characters. But if it now, let's say we didn't borrow, what will happen? Just think for a few seconds. What's going to happen? Okay, let's run the code. And let's look at the errors. It expected a borrow string, but it's only found string. That's the first error. And it says consider borrowing here. So you're supposed to be borrowing, which is not the case. So let's leave it the way it has to be. So just to explain my code again, length takes a string with an operand, and this is a reference. We pass S, the address of S. The function borrows it here. The function basically borrows it. It reads it, and when it returns, the borrow ends. S is still fully owned by main. Key concept. References are like borrowing a book. You can read it, but you must give it back when scope ends. You can't destroy it. Mutable references. What if you need to modify data without taking ownership? Ampersand mut t, exactly one writer. You can have exactly one mutable reference at a time. While it exists, no one else can read or write the data. No aliasing allowed. You cannot create apparent append mute while any other reference, shared or mutable are active. It works like a reader write lock, but enforces at compile time with 0 runtime cost. Prevent data races. By forbidding simultaneous mutation and aliasing, Rust eliminate data races entirely. If your code compiles, you are guaranteed to be free of race conditions. Let's see it in action. I'm gonna create a function called append. We will take a mute string, ampersand mute string, and this is what the function will do. So we going to push world. So this is what we're going to be pushing. So append takes the mute string. So here we pass mute s, the append. The function gets exclusive write access. After it returns, the mutable borrows end, and s is usable again. So let's go to the main now. Let mute s equal string from hello append. So we are appending this, calling the function, so mute s, and after that we're going to print reprinting s. So here we're going to be expecting hello world to print out because we push hello on the stack. So let's run it. As expected, it works. Key concept: a mutable reference allows modification without ownership transfer, but enforces exclusive access. This diagram shows exactly how the borrow checker thinks. Just look at this code. We have on this line we have R1 and here we have R2. These are both active shared borrows and they are both valid. While they exist, the borrow checker blocks any mutable borrow. The timeline diagram makes this visual. R1 and R2 are overlapping the read span. R3 is blocked. The rule: many immutable references or exactly one mutable reference, never both at the same time. This is the borrow checker. This is what the compiler enforces. Once you internalize it, most ownership errors become obvious before you even run the compiler. Here are 3 errors every beginner hit. Knowing them save hours. You have this one here. You used after a move happened. So V was moved, so you get an error here. And error 2, mutate while borrow. You cannot mutate while R exists. And error 3, you have a dangling reference. To fix error 3, the fix for this error is to return the owned string, not a reference to a local. Transfer ownership out instead.